Hello there and welcome to this video on relations and functions. So the first slide which you see on the screen represents an example of a relations, which is simply a mapping of element of one set, which we'll call the domain, into the element from the second set, which is called the range. So as you can see, this relation can be written also in form of set of ordered pairs. So we have one element from the domain, x, and the second element is from the second set, range. So x value comes first, the y value is listed as the second entry, and what we want to really maintain is that the order is in increasing trend. So the lowest value of x is listed first, then next will be 2, 3, 4, and 5. And then we just follow whatever the value of y is assigned without necessarily looking for whether this is an increasing or decreasing order. So that is just a result of the mapping. Moving to the next slide. So to recall the definition, a set of ordered pair is defines a relation. Now, please note that in this particular example right here, where we have domain listed as -1, 0, 2, 4, and 9, is not shown really in that increasing order. So this is not a major problem, but usually, if you were to do that, you want to list -1 as the first element. 0 would be the second ordered pair, and the next one is 2, then 4, and the last one is this. So that would be a much better way of defining a relation when you use ordered pairs. So just make sure that you would follow that pattern. So now, not every relation is a function. A function is defined only if there's only one element from the domain, and that one element has one representative from the range. So in this diagram, you can see that every element of the domain, 1, 2, 3, 4, 5, has only one representation in the range set. So if this takes place, if this is fulfilled, then yes, this type of relation is a function. So not every relation is a function. When you use graphs, then you will be asked to define domain and define the range. So domain represents the x values. So the 3 and 12 is the last value. So first 3 from x-axis all the way up to 12 is the line segment. This is where the line segment is located. So this is why you see x is in between, is contained in between positive 3, including 3, and positive 12. The range, based on the graph, is the set of all values y, such that y, the lowest value of y is 6, and the greatest is 12. So y is greater or equal to 6, less or equal to 12. So you can use an interval notation or inequality notation in this particular case to define domain or range of a function. A vertical line test is often used to determine if a particular graph can be defined as a function. So once you have a situation where from one x value you can generate two y values, this relation is not a function. So that sideways parabola is not a function. because it does not pass the vertical line test. When you have discrete data on the graph, also before you list the ordered pairs, you may observe the following. If you have 2 points vertically lined up, then that would disqualify this graph as a function. When you have ordered pairs listed, you have for one x value 12, there is a y value equal to 28, and for the same value, when x is 12, y is equal to 20. So if I have, again, the same value of x assigned or ordered to two different values from the y elements, then that relation is not a function. Function notation. F of x is the way that we define a function. Often you will see that this is the most commonly used notation. You will also see function where letter h are used, h of x, g of x, but this is the same idea. Whether letter h or g or f is used, this is how we denote a function. So this is read as f of x is equal to 2x squared minus 3x plus 6. So please note that this is not a multiplication of f and x. This is just a way we denote a function. Find the value of the function f of x when x is equal to -2. So the challenge here is to understand that now x is replaced with -2. Everywhere you see the x variable, you must replace with -2, and then you follow the BEDMAS steps. You just evaluate the value of the function. In other words, when the input is equal to -2, the question is, what is the output equivalent to? So through the calculation you get that the value of y, or f at -2, is equal to 20. So f of -2 is equal to 20. Also, it is understood as the following ordered pair. -2 for x generates 20 using this given function. More general statement, find a value of function f when x is equal to k. By analogy from the previous slide, all you do is replace x with k everywhere in the formula, and obviously if you compare this statement with the one above, you see that this represents the same type of function. The only thing that has changed is the variable from x to k. So when you find the value of the function when x is equal to k, after the substitution, you'll see that this is identical to the original question. That is not to say that they are equal, because k and x are not the same. Find the domain of the function in f of x notation, given that f of x is equal to x minus 1. If you recall this type of function from the past, this represents a line. So there is no restrictions for x values. You can replace x with any real number in order to generate its output. So the domain will be written as x is element of R, where R represents the set of real numbers. When you're looking at function g, please note that there is a division statement. When x minus 2 is equated to 0, then the division by 0 would not be defined. So therefore you have a restrictions here that x cannot be equal to 2. Any other value of x would be fine. So the domain here for this function would be x is element of R such that x is not equal to 2. So this is the restricted value that you must include in your statement for any type of question where a rational function is involved. It doesn't work always in the same fashion that there is a restricted values, but you expect to test the denominator all the time. In case you have a square root function, you must be aware of that only positive numbers would be allowed inside of any square root. So this is why x minus 4 can be greater or equal to 0. Then you solve that inequality and you discover that x must be greater or equal to 4. So the domain here is set of real numbers such that x is greater or equal to 4. Please note that any other real number beyond 4 is fine. Equal 4 works as well, but nothing less than 4. And finally, going back to the graph, you have a quadratic functions. We don't know what the formula is, but in order to find the domain and range, please know that the domain is the interval on the x-axis. So you go from 0 to 4. So this is why in interval, in using inequality notation, this is what the value of the domain is. And similarly for range, you would see what is the coverage. The lowest value of y is 1, and then the spread goes all the way to 5. So the range is between positive 1 and 5. The domain is between 0 and 4. If I were to use an interval notation, you would say x is element and square brackets 1, comma 5, 4, I'm sorry, for the domain, so it's 0 to 4. And for the range, you would say y is element square brackets because you include the endpoints. So 1, comma 5. Thank you for watching this video. In the second part of the video, we will discuss end behavior, x-intercepts, discontinuity, and other features of a functions. Thanks for watching, and see you next time.